Okay, assalamu alaikum shabab. Welcome back to the class. I think some of you, shabab, are not aware of how to change their name or how to change their photo. So let me share my screen over here just to show you how you can do this. Okay. So basically, you can see my screen, right?
Yes.
Okay. So this is the Zoom page. All what I have to do now is to click here on my photo, and then I have to go to my profile. Where is it? This is my profile. And a page will be opened, as you see. So here I am not going to use my personal account. I'm going to use my KFUBM account. So I will type in KFUBM and then continue. This is my username and password. And there you go. This is my account right now. So from here, I can change my photo. When I click on edit, I can change my name. I can change my display name. No, my display name cannot be changed, but at least I can use the first and last name. This one, I think, could you display name could be your first name or your nickname or name that you want people to see. I think this is coming from the first and last name. So that's it. Very simple. I don't think it is simpler than this. So let me hand it over now to my iPad again, so we can see the lecture.
دكتور.
Yes.
عندي مشكلة إذا بغير الصورة لازم تكون تحت
You're breaking. I can't hear you يا علي.
المشكلة دكتور إن الصورة لازم تكون
إيش؟
2 ميجا. لازم تكون under 2 ميجا.
Where are you living?
الصور اللي في الاستوديو يعني اغلبهم اكثر من 2 ميجا يجون.
Where are you living يا علي?
الحسا.
Okay, I should come today and I fix your photo for you. How about that?
لا دكتور بس ما اعرف كيف اغير السايز يعني.
Really? What system do you use? Mac or Windows?
Windows.
Well, just open a picture and then go to file, whatever menu, and then you say resize. Come on, I'm not gonna teach you this. It looks like I have to teach you a lot, ya shabab. Okay, do you see now? This is the... Okay, can you see now my
yes.
my screen, ya shabab?
Yes, Sadiq.
Okay. Just give me 1 minute. Do you see my screen again? Do you see the figure, ya shabab?
Yes.
Yes.
This is the figure for the quiz, correct?
Yes.
Okay. All what you need to do, this is Windows. I open the figure, and then I can just go to edit. There is a very short menu here for the most needed things that you usually use, like resize. And when you resize, you can put any definition you want. play with it a little bit, you will reach to the size that is needed. You can crop the image, make it smaller, bigger, whatever. Maybe you cut it this way where it shows your face. You can do whatever you want just by simple click. Is that enough?
Yes, thank you, Doctor.
Okay. I will have to, inshallah, but not today. We are late. We need to move on with the bending section and finish it up. But inshallah, ya shabab, maybe next class, just to give merci for the grader, I am going to share with you my phone screen live, and I will show you how can I scan maybe 100 page in one file, which look like a scanner. I know some of you did that, but there are too many who didn't. So hopefully I'm going to teach you how to do that next class. Okay.
Tamam.
All right. Now, let's move on to our problem. So what are we going to do? We had a discussion on this. I think what I would like you to remember is the following, is that this vise, which look like this, or a clamp, is going to have tension, uniform tension, because of P as a force, right? And it will have bending, which is distributed this way, compression in the bottom and tension in the top. So this is tension, this is compression, this is tension. Okay? Now, what we need to do is to find out what is the geometrical property. In tension, when we say F is equal, sigma equals to F over A, we will need area and we will need force. This is, yes?
How did we know the upper one will be tension and the lower part will be compression?
Well, that's a hell of a discussion, yeah, Abdullah. We did this when we argued that the beam like this is X and this is Z, and these two forces are going to make bending in this direction. So if it's going to make bending in this direction, this part will be bent like this, which will make the top part tension and the bottom part compression. Okay? So now the bending will be MC over I. So what we need I, we need A as a geometrical property. And usually, ya shabab, we start by geometry. So let me quickly draw let me see. I need to clean up this and quickly draw the geometry for us so we can know it. We are having this and this, okay? And this is buoyant D, this is buoyant B, and this is buoyant A. Now, this one is how much? 10 millimeter. This one is 4 millimeter. And the distance from here to there is 20 millimeter. Now, you probably forgot that this one is 4. You probably forgot this, but let's see how far you can remember. Now, what are we going to do? I intentionally split this part into two, okay? The first one is this. The second one is this one. So what I'm gonna do, I'm gonna, draw this table. Okay. All right. So I'm gonna draw this table as we used before. This is part, and then I will have the area in millimeters square, and then I will have y0 bar in millimeter, and then I will have the multiplication of A multiplied by y0 bar, which is going to be millimeter cube. Do you see that? Now, for part number 1, look what will happen. Part number 1, we have 10. I mean, let me make it green. So this is, we have 10 by 4, which is how much in area, Shabab? 40. Okay, so this is 40. Now, the question is, what is y bar? اسمعوا يا اخوان. In y bar هو centroid للarea. فأنا إذا اخترت area 1, the centroid for area 1, I know that it is at the middle of it. The question is where? How far this centroid is from a reference. So what I am gonna do to make it, look easy for me, I'm gonna use a reference which is below, just better than up and looking down. Down, looking up is better. Now then, what should I do? I measure those y's from this reference. So this is my datum or reference if you want. Now, this is how far from the datum, ya akhwan? How far?
20 minus 2.
20 minus 2, which is 18. So this is 18. And then what should I do? I multiply them. This is 720. Then we go to number 2. Number 2, what do we, let me make it probably in red, maybe, or black. So number 2, which is this part now. Okay. Now this one has an area of how much? This distance is 16, and this one is 4. So it is 4 by 16, which is going to be 64. And then, if this is 16, where is half of it? 8. 8 is from the reference located at 8, right? So the y for the second bar is 8. And the multiplication is going to be 512. Now, what should I do? I close this, and then I have another row of the sum. What do? I sum both of the areas, which is 104. This one, I don't need to do anything with it. And I sum the multiplication, which is 1,232. So the real centroid, which we will call it capital Y0, is the sum of AY0 divided by the sum of the area, which is 1,232 divided by 104. How much is this? This is 11.846. Now, where is this located? It is located from the centroid and going to 11. If this is 8 and this is 16, then 11 is probably somewhere here. So this one is 11.846. Does this make sense, ya akhwan? Anybody would think that this makes sense?
Yes.
Why?
It should be between the two bars.
Why does it make sense? anyone with
it should be between the two areas, not one below one of them.
Yeah. If you have only this area, the centroid from the reference is going to be 8. You put more material, the centroid will shift up a little bit, depending on the size of this area. Now, what is important is that the yes يا علي.
الحين لو بنسوي بالاكس بار بيطلع نفس النتيجة ولا هل يختلف؟
شلون كيف؟
يعني احنا الآن سويناه بالواي بار صحيح؟ لو بالاكس بار هل يختلف ولا نفس اللي هو
الاكس بار راح تدش يطلع لك يا علي، راح يطلع لك انه السنترويد is located here. واحنا ما تكلمنا لانه هو سيمتريك، ليش اتعب نفسي؟ انا ما جيت وجبت لك جيومتري مثل هذه like this where some of the material is shifted so the centroid might be located somewhere in the middle. لا. Most of the time we will deal with symmetric geometry with respect to the x-axis, but with respect to the y, you know, the material is stacked differently, and that's why we will have a shift. Okay, now let's move on. Now, why this is important? Because in reality, that centroid is going to be the location of the neutral axis. The centroid is going to be the location of the neutral axis. This is the point where the bending stress reached to 0. So we are going to call this the eccentricity of the no, not the eccentricity. Forget about that word. What I'm going to say is the following. In order to calculate the moment, which is, I will look at the centroid. So if this is, احنا رسمناه باللون الأحمر. If this is the reference, okay, which is right here, 11 is right here. That's 11.8. Now here, 11 point here is somewhere there. So what I am gonna do, that force multiplied by 50 plus this little bit, the moment M, which is equal to P by distance. Which distance? Should you multiply by 50? No. You will multiply it by the distance 50 plus the amount which is gonna take you to the centroid of the cross section. That's the moment. So what we need to do is to find that distance. That distance we are gonna call it E. You know, the eccentricity, which is how far the load is eccentric from the cross section. So it is equal to 50. That 50, you remember it, right? But then plus what? We are gonna add all of this, which is a 20, and then subtract this. صح ولا لا? So we have to add 20 minus 11.846, which is going to give you 58.15 millimeter. Is that correct? Anybody has a question? Okay. Now we move on. Now, if we move on, we will have MZ, which we agreed that it is negative, which is equal to minus 400 multiplied by 58.15, which is going to give you, of course, if you divide this by 1,000, because it's in millimeter, this is going to give you minus 23.26 Newton meter. Okay? We're not done yet, ya shabab. We're not done yet. Now, The cross section is here, like this, right? The centroid is located here. The centroid is at a distance 11.84. We know that this dimension is 16. This is 4. This is 4. This is 10. Now, we need to find the moment of inertia about the centroid. Yes, يا فارس.
معليش دكتور، بس عشان قبل ما تروح للنقطة اللي بعدها، المصطلح اللي قلته قبل شوي، الإي اللي بالإي.
إيه eccentricity.
هذا وش معناته؟ يعني وش يمثل في الشكل عندنا؟
طيب أوكي. الآن الفورس ضاء is located at this level، صح ولا لا؟
صحيح.
صح؟ Now الديستنس من هنا إلى السنترويد هو الإي، وهو عبارة عن 50. فإحنا إيش سوينا؟ 50 هنا عند المستوى هذا.
حلو.
زدنا عليها 20، بعدين طرحنا منها هذا، فالمتبقي هو 50، صح؟
إيه؟
مع الجزء هذا. هذه سميناها eccentricity. ما تبقى تسميها إي، سميها دي distance. سميها distance.
يعني هذا الكروس سكشن حق الجزء اللي تحت، حق اي. اوكي معليش.
شلون؟ ايه لانه هذا هو السنترويد. المومنت راح تسوي الروتيشن، الفورس راح تسوي روتيشن about the centroid.
اي صحيح.
اوكي. now look، اذا تذكرون المومنت اوف انيرشيا I، احنا الحين رجعنا، هذا رقم 1 وهذا رقم 2. ال I1 if you say I1 which is equal to 1/12، صح ولا لا؟ المومنت is this is the centroid, this is the neutral axis, so this is the base. فإذا أنت جيت قلت 1/12 B1 H1 cube which is equal to 1/12. What is B1 يا شباب؟ 40. Is that true?
40.
Sorry. B1 is 10. Is that true?
Yes, it's parallel.
Okay. Yeah. So it is 10 multiplied by how much? 4 cube. طيب. What is I2?
1/12. 4. Multiplied by 16 cube.
Good يا اخوان.
Yes, but it's not about the neutral.
But it is not about the neutral axis. انتوا لازم تفهمون تذكرون ان المعادلة هذه when you apply it you are applying it about the neutral axis about the centroid of each geometry. فرقم 2 السنترويد حقه هنا، ورقم 1 السنترويد حقه هنا. بس احنا نبقى المومنت اوف انيرشيا about what?
About the
about this. So how do you do that?
Parallel axis theorem.
Okay, so you do the parallel axis theorem. So the parallel axis theorem tells you that when you have I 1 over, oh no, let me make it general, right? When you have I about point O, which is any point, you have to find I about G, the centroid, plus you add a term which is what? AD square. So what is A? A is the area of the geometry. فمثلا هنا what is the area? What is the area of this? It's 40.
40.
What is the distance?
It's from the centroid to the neutral axis.
Yes, it is the distance from the centroid to the neutral axis. So that distance 1 is equal to 6.154 and then square. Now, for the other geometry, we have an area which is 64 and a distance, I'm going to make it green, which is from here to there, which is equal to 3.846 and then square. Now, when you find I1 and I2, I, the big one, is equals to I1 plus I2, which is going to give you a 3.88 multiplied by 10 to the power minus 9 millimeter to the power 4. طبعا للمعلومية يعني I1 is equal to 1.568 multiplied by 10 to the power multiplied by 10 to the power 3 millimeter to the 4. So this is in millimeter, and then I converted it into meter. I2 is equal to 2.312 multiplied by 10 to the power 3 millimeter to the power 4. Now I know this. I'm almost done. The last step for me is to find the stress. Now, if you recall again, this is the cross section, okay? And this is the neutral axis. And where is point A is here. Where is point D is there. Now, also, I know that the upper part will be under tension. This is tension. This is all compression. So, if I want to find sigma A, look, then it is equal to the P over A, which is tension, plus a minus my divided by I. Now, what will happen? طبعا يا شباب عشان يعني نكتب المعادلة بطريقة مكتملة. This is mzy divided by iz. So this is going to be equal to 400 as a force divided by the area, which is 104. This area, we found it from the table in the beginning. Plus, there is a minus sign. And then minus 23.26, the moment, multiplied by the distance. The distance from here all the way to the top. Now, this distance is 8.15 and then multiply by 10 to the power minus 3. And then I divide by 3.88 multiply by 10 to the power minus 9. And how much is this? This is going to be 52.7 megapascal. Okay. Now, with respect to sigma D, I will have again B over A, which I know, plus minus mzy divided by iz, which is going to be equal to, again, this part in here, plus, minus, and then I have minus 23.26 multiplied by what? Minus 11.846 multiplied by 10 to the power minus 3. خلاص, and I established my coordinate. This is the zero here. Y is positive here. Y is negative here. Now this is a minus and a minus and a minus. 3 minuses, I will get a negative sign. So the denominator is still the same, 3.88 multiplied by 10 to the power minus 3, minus 9. And then what you will get sigma D, which is equal to minus 67.2 megapascal. Good يا أخوان.
يا دكتور.
Yes.
The P over area.
Yeah, what about it?
Should you consider it because when we take the formula it was only mzy over iz, and we take the moment and put it in the, we use the load only to find the moment.
You mean this one? You mean this one? This equation?
Yeah, this equation, and we use the load to
Hey,
find
بس Faris. This equation for two moments, one about Z, one about Y, both of them are creating normal stresses in the X direction. الحياة مو كذا. ممكن أنا أجي
قصدي يعني MZ Y over IZ alone.
شوف ممكن يجيك يوم السؤال هذا يكون زيرو وهذا ما يكون زيرو. يمكن يجيك يوم سؤال في هذا وهذا بلس B over A. We don't know. Whatever is there is there. Whatever is not there is not there. In this problem, we had one moment. Okay.
Yes.
We have one moment and one tension. That's all.
بس يا دكتور كيف أعرف متى أعرف إن في P over area؟
شلون؟
أنا عرفت إن في فورس وأنا قد حاولت أحل المسألة بس أنا يعني ما اعتبرت إنها مومنت بس the P cause moment on this section وما
هذا غلط.
P over area.
إيه هذا غلط.
عارف إنه غلط لكن عشان كيف أعرف إن عندي P over area إني لازم أحط لها ترم زيادة.
أوكي. شوفوا يا أخوان هذا يحتاج له training. أوكي. You need to be trained. إنك أنت لا قبل ما تهجم على المسألة وأهم شيء إنك تحط معادلة وتعبيها أرقام وتطلع أرقام ثانية. You need to spend 1 or 2 minutes thinking. The only way I can advise you to think about it is this. اسأل نفسك سؤال. لو تخيلنا بأنه هذه الكلام مصنوعة من مادة ما يصير لها بندق. يعني بس تخيل إنه هذه مصنوعة من مادة ما يصير لها بندق. وجيت أنت وكبستها من هنا وظليت تكبس. الفورس هذه حتزيد. إذا المادة ما يصير لها بندنج إيش راح يصير للكلام؟ إيش تتوقع؟
تنشن ولا
إيه الكلام هذه إيش راح يصير لها؟ هي الآن شكلها كذا صح؟ زيد التنشن إيش راح يصير؟ راح تصير كذا. زيد التنشن حتصير كذا وحتطول وتطول. فاهمني؟ طيب imagine now إنه الكلامب هذه مصنوعة من مادة غريبة ما تطول. ممكن يصير لها بندنج بس ما تطول. لما تزيد الفورس راح يصير حق هذه الكلامب bending like this. تزيد الفورس أكثر راح يصير لها bending like this. تزيد الفورس أكثر راح يصير لها bending like that. Now in reality both of them are happening together. لأنه ما في material إلى اليوم موجودة على الأرض نعرفها إحنا كذا تتحكم فيها. هذه والله الماتيريال بس حق تنشن، هذه الماتيريال حق بندنج، ما في. So نصيحتي يا أخوان the only way you will become a good stress analyst هو أنك أنت you can imagine the deformation. من المفترض أنك أنت تتخيل قبل ما تدخل في تساؤلات كيف التنشن وكيف البندنج، أنت تخيل إيش بيصير للكلامب هذه how does it deform. من المفترض أنك تصل إلى نقطة أنك تقول أنا بغض النظر عن التنشن. يعني شوفوا شباب أنتوا علموكم في السيفل انجينيرينج بأنه علموكم هذه الطريقة، قالوا لكم بطريقة يعني constructive way، طريقة إنه يا شباب إذا أنت عندك force هنا this is what they told you I'm pretty sure you want to analyze this cross section what should you do؟ في أحد يتذكر وش قالوا لكم؟ قال لكم الفورس is acting here بينما انت تبغى تشتغل هنا. فانا يعني بطريقه او باخرى اتوقع ان الاستاذ قال لكم ده. هل تقدر تقول ان ما في شيء هنا زيرو ستريس؟ لا. فالطريقه كذا ترك كذا ما ادري تعجبكم ولا لا. يقول لك شيل الفورس هذه وحطها هنا. بس اذا حطيت الفورس انت جبتها من هناك الى هنا حركتها ديستنس. فاذا الفورس لما تحركها لازم
قطع يا دكتور.
قطع الصوت.
قطع الصوت يا دكتور.
Okay, Akhwan, I'm very sorry. It seems like I had a hiccup here. Can you hear me now?
No problem, Doctor. Yes, we can hear you.
Okay. So this is what I was saying. I was saying, you know, you can look at the problem in another way. Remove the forces here, just ignore them. Move the B down with its moment. انت بس تحركها لازم تعوضها بmoment. And this is it. You have a force and a moment. أنا اللي كنت أقول بأنه you can think of it this way. إنك أنت الفورس you don't want to analyze the section here. You want to analyze it here. So move the force in the cross section and substitute the moment. Can you please turn on your camera يا شباب? I'm gonna take the attendance and then we will continue. Okay.
Okay.
With time يا أخوان you will get better. I know it is hard in the beginning. But because we are going to have too many problems, you will feel yourself better, inshallah, soon. Practice. Just keep practicing. Okay, Faisal,
Yes.
where are you? Faisal, thank you, Faisal. Yusuf? Yusuf?
موجود دكتور.
Where are you?
افتح الكاميرا يعني.
Yes. You don't know that يا يوسف? Thank
بس
you.
اول 10 دقائق اتفقنا.
When we need it. I didn't do the 10 دقائق في البداية يا شباب. حمد؟
Yes, Doctor.
Okay. قحطاني علي؟
Yes,
Okay يا
Doctor.
علي. I see you. يوسف اليوسف؟
Yes, Doctor.
ماجد العباد؟
Yes, I'm here.
Where are you, Majid? Yeah, I can see you, Majid. Thank you. حسين العلي?
Yes, Doctor.
Okay. محمد؟
Yes.
Okay. حسن؟
Yes.
مبارك؟ مبارك, where are you? Ahmed?
Yes, here.
Zari. Okay, thank you, Ahmed. Ali? Ali is here. Haji? معجب؟
Yes, doctor.
Where are you?
Yes,
Okay. Sultan Harbi?
موجود يا دكتور.
Yes, I can see you. Abdullah? Hijab? Okay.
Yes.
Sultan?
Yes.
Roshan? Where are you, Sultan? Yeah, I can see you. Good. Faris?
Yes.
Okay. Abdurrahman?
Yes, doctor.
Okay. Khalid? Ataybi?
Yes, doctor.
Abdullah Al-Awfi?
Yes دكتور.
Faris? Okay. Thabit?
Yes, doctor.
Ali? Ramadan? Okay, I see you. Hashim? Sada?
Yes.
And Majid?
Yes, doctor.
Muhammad?
Yes, doctor.
Okay. Ahmed? Sultan?
Yes, doctor. Yes.
Mish'al? Mish'al? Yami? Oh, this is really interesting. It feels like Thursday, truly. Walid?
Yes دكتور.
Walid. Muhammad?
Yes دكتور موجود.
Rashid. And then Abdullah?
Yes, doctor.
Ahmed?
Yes, doctor.
Okay. Okay, let's get back to business. Gonna stop the sharing here. We talk about 2 minutes. It's a good break for you and everybody. Okay. Okay. Now, what we are supposed to go to discuss is the shear stress, which, ya shabab, can be generated. The first, way to generate a shear stress is definitely through torsion. Okay. Now, the torsion, as you see, twist the member, and it is usually performed, okay, by applying a moment which has the axis of the moment, which is the direction of the thumb, is along the axial direction of the member. And that's how you twist it. In the end, if you look at the deformation in the represented by those little squares, okay, you will see that these squares will be misoriented or rotated. You see how they get deformed? They were like this. And now those ones are deformed in a, I don't know, honestly, I'm not drawing it well. So they will get deformed like this. That's how. So torsion, ya akhwan, is very important. Similar to bending. Inshallah, في chapter number 7, when we talk about shaft, which are this huge mechanical element of all rotary equipment, we will see that mostly we will focus on bending and in torsion. Hopefully later we will explain to you why. So this is just an illustration of how torsion is applied as a rotation. And this is finally, I have a figure here showing the right hand rule with the thumb pointing upward. So this is considered a positive direction. the other direction will be considered as negative. What is interesting about torsion is the fact that if it is applied within the elastic regime, within the elastic region, it will generate maximum torsion in the surface, okay, furthest from the center. And it will have a zero value in the center of the cross-section. That's the first thing. The second thing is that the distribution is linear. Now, this distribution is linear as far as the material is elastic. If the material is not elastic, this distribution will become non-linear, okay? So, as much as non-linear deformation is interesting, but we are not, of course, going to talk about it. It's too much. So, what is the other way to generate shear stresses? Is through transverse load, which are the load that act parallel to the surface, but in opposite direction, and they try to shear off the material. In this way, if you look at this example, then basically the shear stress will be acting on the surface like this. This is the bottom face. The upper face will have an opposite sense. And that's how you shear things off. Now, what are we going to do in the next class is to discuss how do we calculate the shear stress resulting from bending. Now, somebody might ask, how? وش دخل الموضوع? I'm pretty sure you will be confused. You would say, يا جماعة الخير وش السالفة? We are talking about bending. وش دخل الشيء? That's a very nice question if you have it in mind. But let me tell you why. The answer is very, very simple. If you remember from the quiz, for example, when we draw the shear force diagram and the bending moment diagram, let's just, for the sake of argument, assume that we have a shear force like this, and then like this, and then like this. There it is, a very simple diagram. Now, we agreed that the bending moment is the area. So I will have a bending like this and like this. Okay, now that's the question. What is this length? This is X, this is X. X represent the length of the beam. So in reality, this could be an I-beam sitting, ya shabab, on two supports with a perpendicular force acting on it. So let's say this beam has a cross-section just similar to the one we had before. The idea is very simple. If I ask you to find the bending stress at this location, okay, you will use the equation sigma equals to MC over I. You will find I just like the way we did before. You will go and have the centroid here, and this is C, no doubt about it. And what is the value of M? Is this one. That's where I want you to find it. Maybe I will ask you to find it right here. So you will use this moment. It doesn't matter. What matters is this. What is this value? What does that mean? What is this value, Shabab?
Maximum bending moment.
This one. This one. هذه يا أخوان. What is this?
Shear force.
Shear.
Is a shear force. What is this shear force is gonna do?
Bend the
shear
beam.
يعني يعني يا شباب الشير فورس هي الطيبة والزينة والمومنت هي الشريرة. هذه تكسر الدنيا. وهذه ما تسوي شيء. ها؟
لا
إيش
كله
رأيكم؟ هذا
ديبندنت
كلهم مصايب. Yeah. So what are we gonna do next is you will see that whenever you have a shear force diagram, you will generate a bending moment diagram. طيب البندing moment diagram, we determine it for bending, beams under bending. And in only very critical situation, يا شباب, there will be only bending and there will be no shear. But most of the time, ما هو يا شباب, مو البندing هو نفسه يجي من الاريا حقت الشير، فما في فايدة. انت هو ملاحقك. You can't escape. Whenever there is a bending moment diagram, there must be a shear force diagram. If there is a shear force diagram, you will ask yourself, how is this gonna act on the subject? So next class, inshallah, we are gonna show you how to deal with the shear force اللي جاية automatically when we have bending. Okay, Shabab, thank you so much. Have a nice weekend.
دكتور
Yes.